This is conditionals, operators, and loops for Elevate the Future San Diego Python. So first let's go over operators. So first we can talk about comparison operators. So the first operator is the greater than operator, which just obviously means greater than. So comparison operators return true or false. So they basically will result in if it's true or if it's false. So looking at the greater than operator, we can see 5 greater than 3 would be true because obviously 5 is greater than 3. While 5 is greater than 5 is false because 5 is not greater than 5. And 5 greater than 10 would also be false. So that's some examples of using that operator. The next operator would be the less than operator. So 5 less than 3 is false, 5 less than 5 is false, but 5 less than 10 would be true, since that's the only example where it's a true statement. The next operator is less than or equal to, which is similar to the less than operator, except if it's equal to, it will still be true. So these two examples are the same, but whereas 5 less than 5 would be false, 5 less than or equal to 5 would be true, since it can be equal to as well. Again, it's a similar thing for greater than or equal to, in which case these two are the same as a greater than, but if I look 5 greater than or equal to 5 is true, while 5 greater than 5 would be false. So that's the main difference if you add an equal sign, if you do greater than or equal to or less than or equal to. Then there's the equal to operator, which is just if one number is equal to another number. So a key thing is to make sure you use 2 equal signs. So as you see, it's equal. Because otherwise, if you use 1 equal sign, it's just assigning it. If I do variable a is equal to 3, then I use 1 equal sign. But if I'm trying to compare 2 numbers, I'll use 2 equal signs. So 5 equal to 3 would be false, 5 equal to 5 would be true, and 5 equal to 10 would be false. Then there's the not equal to operator, which is an exclamation point and then equal to. So you can just think of the exclamation point as not, and then the equal sign is equal to, so not equal to. So then I would have 5 would not equal to 3 would be true, but 5 not equal to 5 would be false, and obviously 5 not equal to 10 would be true since they're not equal. So additionally, there's a couple more conditional operators. So the first one is and. So these and or are 2 conditional operators which combine 2 booleans together. So you could combine it with 2 conditional. You'd usually combine it with 2 conditional operators. So and means that 2 conditions must be true for the whole statement to result in true. For instance, 10 greater than 5 and 5 not equal to 5 is false because the 10 greater than 5 component is true, but it says and 5 is not equal to 5, which is false. So both of these need to be true for this whole statement to be true. So then it becomes false. Meanwhile, if we do 10 greater than 5 and 5 equal to 5, we can see that this and 10 greater than 5 and 5 equal to 5 are both true, so this will result in a true statement. 10 less than 5, which is false, and 5 not equal to 5, they're both false, so the statement will result in false. Or means that one of the statements must be true, or 2, but you do not need both of them to be true. So for example, 10 greater than 5 or 5 not equal to 5 is true since one of the conditions are true, which is 10 greater than 5. Meanwhile, if I do 10 greater than 5 or 5 equal to 5, they're both true, so this will also result in true. But if we do 10 less than 5, which is false, and 5 not equal to 5, which is false, they're both false, so this results in false. And in our next section, we're gonna use these conditional operators and if statements in the next section. So that's why conditional operators are useful. And as you can see, you can use them with variables and other things. So now let's look at a few math operators, which will be useful if you want to do complex math. So 2 star signs or multiplication signs or whatever you want to call them, that means to the power of, which makes sense as one multiplication sign, star multiplication sign would just be 5 times 2. But here, this 2 of them means to the power of, so this would be 5 to the power of 2, which would be 25. And then if I use 4 to the power of 3, that'll be 64. And it's because 4 times 4 times 4, like 3 times, would be 64. Well, if I just do 5 times 5, which is just multiplying 5 by itself 2 times, then it's 25. So that's how the power of operator works. Then there's the module operator, which is just a percent sign. This is basically, you can just think of it as a remainder operator. So what it does is it divides the two terms and then sees what the remainder is and returns that. So 11 modulo of 5 is 1, because when I divide 11 by 5, the remainder is 1. Meanwhile, if I divide 12 divided by 4, which would be 12 modulo 4, the remainder is 0, so the result of the operator would be 0. And then finally, the last math operator would be the plus equals operator, which is more for like adding an amount to a variable. For instance, let's say a starts at 3, then we can do a plus equals 1, which will make a 4. So this increases a by 1 if I do a plus equals 1. If I want to like increase it by like 5, then I can do a plus equals 5. So if a starts at 2, then it'll be 7. So the plus equals operator is useful if you want to increment a variable, but you just want to make it like 1 higher than the current state. Now we can talk about if-else statements. So if-else statements are a way to use conditionals and do stuff based on what the conditional is. So we actually use if-else statements a lot of the time in real life. So let's think about real life. So one situation might be, if it is raining, then I'll drive my car like to school, else I will walk. So we do this all the time in real life. So now we're just applying this to programming. So in Python, so we can create a variable first called a, and we'll set it to 3. And then we can use our if statement. So if a is greater than 10, so this is like if it is raining. So here it is raining is our conditional, and here our conditional is a is greater than 10. Then we make sure to put a colon, which tells Python the next statement will be run if a is greater than 10. So this returns true. Then here we want to make sure you want to put a tab and make sure that everything that's inside the if statement is tabbed. So like see this print statement, there's a tab before it. So in this case, we check if a is greater than 10, we will print to the console a is big. Else or otherwise, we would print a is small. So like printing a is big and a is small is like an action, just like driving my car and walking. So let's look at what would actually happen in this example. So a is equal to 3. So 3 is not greater than 10. So we will not do what is inside the if statement. So we'll skip this statement. And we'll instead go to the else statement, which says print a is small. So in this case, if a is 3, we would print a is small. So now we can look at some more examples. For example, if we set a is equal to 3 and b is equal to 3, and we could say if a is equal, so there's two equal signs here, which again, just remember to do that. So if a is equal to b, and then just remember the colon again. Well, if you don't do the colon, then the program won't work. So if a is equal to b, we would print yes, else we would print no. So since a is 3 and b is 3, they are equal, so we'll go to the statement inside the if, which would print yes. Meanwhile, if a is equal to 3 and b is equal to 4, and we say if a is greater than or equal to b, and print yes if it's in the if statement, and the else statement will print no. Since 3, which is a, is not greater than or equal to 4, which is b, then the output of this would be no. Now, let's look at elif statements. So, elif just means else if. So, otherwise if. So again, let's look at this in a real life analogy. So, let's say there's a prize system based on how many stars I have. We could say if I have 10 or more stars, then I get 5 prizes. Otherwise if, or you can think of this as else if, I have 2 or more stars, I get 2 prizes. And we could just have an else statement at the end if I have less than 2 stars, or I could just say else I get 1 prize. So now let's apply this to programming. So we can set a variable a, and then we can say if a is greater than 10, we could print a is big. Else if, so we're saying like if it's otherwise, if it's greater than 5, then we could say it's medium. And finally, if it meets none of these criteria, then we could say that A is small. Looking at A is equal to 6, let's go through this code. So if 6 is greater than 10, we would run this code, but 6 is not greater than 10. So then we move on to the elif statement. So we see, is 6 greater than 5? Well, yes it is. So then we would print A's medium. Meanwhile, if A was 11, then we could just say, if 11 is greater than 10, which is true, we print A is big and we can skip the rest of this. So the next thing we are going to talk about is loops. So the first type of loops is called for loops. So loops in general are used when you want to repeat a set of code multiple times. For loops are generally used when you want to loop over like a string, an array, or you know how many times you want to loop. So let's look at a couple of examples of for loops. This first example says, for I in range 10, print I. So how does this exactly work? So first we say the for keyword, which tells Python that we want to have a for loop. Then we can create a variable which would say what our current iteration is. And then in, so we're saying for each thing in range 10. So range 10 returns every number from 0 to 9. And then key thing, remember this colon goes at the end here. Then we tab everything inside the for statement. So for I in range 10 would go, I would be 0, 1, 2, 3, 4, up till 9. So this print I would be run for each, I would be 0 through 9, and it would run for each I from in 0 to 9. This is what range 10 is. So remember, programming, usually counting starts at 0, and so that's why it goes 0 through 9 if I do range 10. Like if I did range 9, then it would go 0 through 8. So if I ran this code, it would print 0, 1, 2, 3, 4, all the way up till 9. Now, we can also use for loops to loop through like characters in a string. So let's say you have a string called hello world, and it's equal to a string hello world. Now we can loop through each character as I, so that the current character will be stored in I. Same way here, the current number is stored in I. So we say for I in, instead of using range 10, which would be number 0 through 9, we would go in this string, which is called hello world, and we'll print I. So the result of this, it would print like H, E, L, L, O, and it will print like every character of the string. Now let's talk about the other type of loop, which is a while loop. So while loops repeat while a condition is true. So example of this in real life would be, while I'm hungry, keep on eating. So like once I'm not hungry, then I would stop eating. So we could actually implement this example in a Python program. Let's say I can eat 10 hamburgers, okay? And the food eaten, or the current number of hamburgers I've eaten, would be 0. So while the amount of food that I've eaten is less than the food capacity I'll eat, and we can print eating food and add 1 to the food eaten using the plus equals operators we talked about earlier. So this basically would keep on eating hamburgers or whatever food you want. It will keep on eating that food until it reaches my food capacity. So it would print eating food 10 times, since my food capacity is 10 units or 10 hamburgers or whatever, however you want to think of it. So here it'll keep on printing eating food until I'm full. Finally, once it's done with that, I'll print I'm full. So that's what while loops are useful when I want to keep on doing something while a condition is true. So like this is the same thing as I'm hungry, since I've eaten less than like my capacity. So there's a couple of important statements that you can use in loops to modify them, sort of. So the first one is break, which just completely exits out of the loop and moves out of the loop and continues on to the next, whatever's below it. Meanwhile, continue ends it ends the current iteration of the loop rather than just ending the whole entire loop. To better understand these things, we can look at a couple of examples. This first example has a variable called count, which is set to 0. And it goes while true. So since true will always be true, this would theoretically just keep on running, except we're using the break statement. So here we check if count is greater than 5, we will break, otherwise we'll print count and keep on adding 1. So this would do is like count is 0, count is not greater than 5, it would print 0, it would add 1 to count, so count would be 1. Now it would repeat. And then it would add count to 2, so on. And then when we reach count is 6, by the time count is 6, 6 will be greater than 5, so then it will break. This whole loop will end, and we'll move on to the next line, which would be this loop. So, now, let's look at how we can use continue. This loop goes for I in range 10. So, again, this is range 10 is the numbers from 0 through 9. So, we check if I modulo 2 is equal to 0. So, this means the remainder of I, when I divide I by 2, would be 0. In other words, this means if I is divisible by 2. So, like 4, if I was 4, then percentage times 4 divided by 2 produces a remainder of 0. Meanwhile, if I was 3, it would produce a remainder of a 1 and not reach this statement. So how the continue works, I starts at 0. So 0 divided by 2 produces a remainder of 0. So it continues. It skips this print statement and goes on to the next I, which is 1. 1 percentage sign 2, or 1 modulo 2 is 1. So it does not execute this continue statement. Instead prints I. It keeps on repeating this for each number 0 through 9. So the thing is, since the even numbers it will skip the print, so this program would only print all the odd numbers from 0 through 9. The next thing we're going to do is we're going to apply these Python concepts into some activities. The first activity is a calculator project. So the way this calculator project works is that our user is going to enter a number, and then they're going to enter a letter standing for the operation they want, which would be like A for addition, M for multiplication, and so on. Then they would enter a second number, and we would be expected to compute the operation. For example, if they entered 1A2, we would be expected to print the result of 1 plus 2, which would be 3. Meanwhile, if they did like 1D2, we would be expected to print 0.5 or 1/2. So, let's start this program. The first thing I want to do is collect their input. So, we can create a variable called number1 to store their first number, and we'll take an input and we'll ask them, please enter the first number. Alright, so now that we have this, there's one problem with this. We need to make this an integer rather than a string so we can do math with it. We can do this using the int function, so we just put this inside int with the parentheses. This will make sure this is an integer and not a string. Next thing we want to get is their operator, which we'll do an input. We'll say, please enter the operator. So this string that we're putting in input is like the prompt that we're going to ask them. We can also tell them what the operators are, so we can say A is addition, M is multiplication, D is division, and S is subtraction. Alright, okay, now we don't need to convert this to an integer since it's going to be like a string, which would be like A, not like a number like 1. Finally, you want to get our second number, which will be basically the same process as getting the first number, except we would just ask them to enter the second number, and we put it in a variable called number2. Okay, so now we actually want to do some stuff with our variables. So, for the first thing we need to do is check what the operation is, so that we know whether it's like addition, multiplication, subtraction, division. Well, we can use if statements and the equal operator. So we can do if, and then we want to check if our operator is equivalent to the string of A, which would mean it's addition. In this case, we can have a variable called result, and we can set it to the addition of number1 plus number2, since the operator is addition. So, next, we can use the elif operator since we're saying other. So if it's addition, otherwise, if it's, let's say subtraction, which would be S, then our result would be number1 minus number2. Okay, then we can use elif again. We can say if the meanwhile, we can say if it's division, so else if it's division, result could be number1 divided by number2 since it's division. And finally, if you want to use, we can just use an else statement. We can use another elif statement to check if it's multiplication. If it's multiplication, we can have result equals number 1 times number 2, since we want to multiply it. Finally, we want to actually do something with the result variable, so we can just print it. So we can just print result. So as you see, we're using the elif statements in order to get the result for the numbers, and then do the calculation. Now, if I run the program, I can run it, and it'll ask me to enter the first number, as we see in our input. Let's say I enter 10. Okay, then I can enter the operator, which it tells me A is for addition, M is for multiplication, D is for division, and S is for subtraction. Let's say I want to multiply a number, so I can do M. Finally, I'll enter my second number, which in this case, let's just say we want to multiply 10 by 5, so we could enter 5. As you see, it prints the result of 50, which is what we wanted, which is just multiplying 5 and 10. So this is how you'd build this calculator project. The next activity we have to do is experiment with turtle graphics. So here I'm going to show you this turtle graphics program, show you how it works, and then I'll explain how this program line by line. So let's run this program just to see what it does. So what it does is it creates a window and then creates this cool spiral effect. So how exactly does this work? So after this runs, I'll explain it. So the first line is import turtle. This just tells the Python program that we want to use turtle graphics. If I hover over it in rebel.it, it explains how turtle graphics works. It says it's popular way for introducing program to kids, which is because it's a really easy way to create graphics like this, which is really easy for kids to learn. Let's move on to the next line. So this creates an array called colors, which has 6 different colors: red, purple, blue, green, yellow, and orange. As you can see, these are the colors used in the spiral, and we will switch between them in the code below. The next thing we do is we create a variable called t, which is equal to turtle.pen. So this gets the pen from the turtle so that we can actually draw stuff using the figurative pen on the canvas or the window. Then we set its speed to 0, which the way that turtle works, 0 is actually the fastest speed. Finally, we want to set the background window of the window. As you can see, it's like a black background. This is because we ran turtle.bg color black, which is bg just standing for background, and this would set the background color to black. Now we're using an application of for loops in order to create the complex graphic thing like this. So our for loop runs for x in range 360. So it runs from 0 to 359. It sets the pen color to x modulo 6. So this is really special because it allows us to loop through the colors so that it creates this cool effect. So how this works is basically whenever you take the remainder of something, it will always be from 0 to 1 minus that number. So the remainder of dividing by 6 would always be from 0 to 5, because like 5, the remainder of 5 when I divided 5 divided by 6 would be 5, but if I go to 6 and it like resets back to 0. Obviously you want to loop through the elements in the array, so this allows us to do that. So like let's say x is 0, then it will start here, 1 it would go here, and so on. But when we reach 5 it will go to orange, and when we reach 6 modulo 6 would be 0, so it loops back to red. Which this allows us to like go in a cycle of the colors and create this cool effect. The next thing we do is we set the width of x over 100 plus 1. This allows us to have an increasing width. As x increases, this term increases, allowing the width to become slightly bigger each time as we divide x by 100. So like as you can see, the lines like out here are much thicker than the lines in here because it becomes gradually thicker as the lines progress. Finally, we go forward an x distance, and as you can see, as x increases, the length of the line increases. Like look at this tiny line here compared to this much bigger line here at the outside. This is because we move t forward x. Finally, we turn it left by 59 degrees. So this allows us to actually like create the spiral. So like if I run the program again, as you see, it like the line turns to create the shape. So this tells it to turn left 59 degrees. So that's basically how this program works. And if you want, you can try it on your own at repo.it or on any other Python editor, and you can experiment with turtle graphics and create your own cool graphics. So our next activity is to create a multiplication checker, which has our computer or the Python program ask the user a multiplication question, and then we want to check if they actually answered it correctly. So to make this easy to change the two numbers, I'm going to create some variables, which would be number 1 and number 2, which can be any two numbers you want, which we want the user to multiply. So you can make these whatever you want when you're testing it, and it should still work. Or that's how we want our program to work. So in addition to setting our variables, we also want to get the answer from the user. To do this, we want to use the input command, and we want to ask them what is, like, let's say number 1 times number 2, right? What's number 2? The problem here is we actually want to display number 1 and number 2. You can actually add strings together in Python. So here what I'm going to do is, so what I'm doing here is I'm adding some strings in Python. So what we're doing is we're doing what is, and then we're using the stir command to convert number 1 into a string. So it would say like what is 7 times number 2. So what this does is so you're basically adding the strings together. Like I could print like, so like again, just to demonstrate this, I could print like hello, plus world, and then it would print like hello world. So you can like add strings together like that. We also want to do the same thing for number 2. So here we can again use the stir command and convert it to a string. If we see this, we just want to make sure this part works. We can see it says what is 7 times 5. If I change the variables, like maybe 8, then it will also work. And then it would say what is 7 times 8. One thing we want to do is we just want to add a space at the end, just so that it's cleaner, so I can just do plus space. And we can add a colon, or in this case we would add question marks since we're asking them a question. Okay, now we've collected their answer. This program is pretty straightforward from here. So we want to just check. We want to check if their answer is equal to number 1 times number 2. If this is true, we want to print that they're correct, while otherwise we want to print that they're incorrect. Okay, so here we're just checking if the answer that they put in is equal to the number 1 times the number 2, so the multiplication of these two numbers, then we print correct, otherwise we print incorrect. So let's try our program out. So it asks us what is 7 times 8, so I might put 56, and then it's saying incorrect. So obviously there must be a problem with our code. So let's look closely. So as we see, we're comparing answer and number 1 times number 2. The key thing here is we forgot to convert input into a number. So, as we know in Python, if I try to compare a string to a number, it will never say it's equal. What I needed to do was use the int command to convert this string, which is returned by input, into a number so we can actually compare it to 7 times 8. Now if I run this program again, and I add in 56, then it says correct. So as we see, we fixed our program. Now if I try putting like an incorrect answer, like 60, then it would say incorrect. In addition, I can change the variables of the program. Let's say I change number 1 to 5. Then here I'll put in 40, then it says correct. So this is basically a modular multiplication checker. I can just change these numbers so that we can ask them any multiplication problem that we want. So our final activity is to make a prime number checker, which given a number through input determines whether it's prime. So here I'm just going to clear out my previous code and let's start coding this. The first thing we want to do is get the number that they want to check. We can store this in a variable called number, and we can take the input and ask them enter a number. So we just ask them to enter a number, and they would enter the number. Now our next step is to actually check if it's prime. So the definition of a prime number, if you recall, is that it must have exactly two factors, or two positive factors. So this is for checking positive numbers are prime. This program may not work for negative numbers. But anyway, so what we want to do is we want to count the number of factors. So we can probably put this in a variable. Right now we don't know how many factors it has, so we can just start it at 0. Now we want to write a for loop. So what this does is we want to loop through all the numbers from 1 to number. But as you recall, the range command, it stops one short of the end number that we provide. So this is a special version of the range command where I'm specifying that we start at 1 rather than 0. And then we're going up to number. And we're just adding a +1 since the range command, it ends 1 before whatever we specify as the endpoint. So what this does is it would loop through each of the numbers that we want to check is a factor. And then we can just add it to the factors variable if it's a factor. So we can, to check if something's a factor, we can do if number, so when I divide number by I, is the remainder 0? Because if the remainder is 0, then that means it divides cleanly and that, it's a factor. If this is true, we can add 1 to the factors variable using the += operator. So this for loop will run for each number from 1 to number, and now we have a count of the factors. So we can say if factors is equal to 2, then we'll print number is prime. And otherwise, we know that it's not prime. So now we can run this program and see if it works. Let's try this with a prime number, such as 3. So now we see that there's an error. We can only concatenate str. It says you can only concatenate str, not int str. This mentions data types of string and int. So this probably means that we made a type conversion mistake. As we see, we forgot to convert input to an integer again, so we can just use the int command to do this. It's really important to read the error messages, and then you can see what line it says. So for instance, it says for I in range number and number +1, so we look at number and we would think, oh, what did we do wrong with number? Here we can see int. So this is a really important part of coding, is actually troubleshooting your code. So now let's try this program again. This time, let's try entering 3. It says the number is prime. As 3 is prime, it has two factors, 1 and 3. If you look at a number that isn't prime, say 6, then it would say the number is not prime, as 6 has like 4 factors, which is, I believe, 1, 2, 3, and 6. For a recap of our lesson, the things that we learned were conditional operators, such as like greater than or equal to, less than, and the or operator. We learned advanced math operators, such as plus equals to the power of and the modulo operator. We learned if, else, and elif statements, and we learned for loops and while loops, and we applied these to real life examples.